Right. Then when we are talking about the waves transfer energy from one place to another. And there are a few types of waves. In there, we mainly talk about the light, right? We mainly talk about the light, right? Because the major sections are reflection and the refraction of waves. That means reflection of, under this, we are talking about the reflection of the light, right? Hari. First one is reflection of the light. Reflection කියන එක දැකලා තියෙනවද? මීට කලින්. Flower, are you familiar with the reflection? If yes, where? Kitnudi? Chance is yours. Sanumi, put into the chat box if it is yes or no. I are you have I think you have experienced the reflection in some day. Lamai,
Yes, sir.
right, very good. Now you have experienced the reflection here. Hari. එතකොට light is very important form of energy for man. Let us briefly recall what you have learned about the light in grade 6 and 7, right? You have covered, I think all of you have covered about the light in grade 6 and 7, right? According to the activities in the table 40.1, what are the conclusions? Right. First one is, here you have a small tiny hole, then you light up a torch here, and the light beam is going through this tiny hole as a beam. Then there are cardboards with a hole, and they are aligned to one another, and a candle is lighted up here, and we are looking at the light from this hole, right? Then the other one is the final third one is, use a laser torch, and there is a plain mirror. Then the laser beam will be reflected, right, after touching the mirror, right? I want to highlight this reflection, right? Right. Sehansa, read this. Read from light from here to here.
Light is composed of very thin light rays which travel in straight lines. Light travels through a vacuum or a transparent medium in straight lines and reflects when strikes on a reflecting surface mirror. Bouncing back of light ray into the same medium when strikes on a surface is known as reflection of light.
Right. Light එක කියන්නේ මොකද්ද? Light beam is composed of thin light rays, right? Light එක හැදලා තියෙන්නේ thin is a collection of thin light rays like this, right? They are parallel to each other, right? They don't go here and there. They they just straight and moving towards a one direction, right? Here, light travels through a thin light rays which traverse a straight lines, right? Like this, and we call them together as the light or light beam. Light travels through a vacuum, right? To travel, light doesn't want any media, right? It can travel through vacuum, which do not contain any particle of air, right? Vacuum එකක් ඇතුලෙන් වුණත් light එළියකට යන්න පුළුවන්. So, I'm asking a question now, right? Will the sound able to travel through a vacuum, go through a vacuum? Sound waves, the sound waves. Is it going through a vacuum? As young scientist, you have to answer this. Will the sound waves travel through a vacuum? Will the sound waves travel through a vacuum? Sehansa kitnuli? Sanui. Think an answer. Will the sound waves travel through a vacuum? You have studied, right? A vacuum means there are no any, any, but any particle of air, at least no air, right? Will the sound waves travel? No, sound cannot travel through a vacuum, right? But the light waves can travel through a vacuum. To to that means sound waves needs air to go from some point to another, but light don't want, right? Light travels through a vacuum or a transparent medium like water, right? Air is a transparent medium. Am I correct? You can see through air. So it is a transparent medium. Am I correct, Kitnuli?
Yes, sir.
Right. So give me an example for another transparent medium. Anyone? Say answer. Right. Water. Water is a transparent medium. Am I correct?
Yes, sir.
Right. Very good. Right. So light is traveling as straight lines and reflects when it strikes on a reflecting surfaces. Light reflect when striking on a reflected medium like a plate mirror. Right. What is reflection? Bouncing back of light ray, right? Ray into a same medium. That means if it is come through a through air, it is reflected into again air after touching the plane mirror, right? If it is come through water, right, it will reflect again into the water, into the same medium. When it strikes on a surface, is known as reflection of light, right? Bouncing back again, it turns, it changes the way of its direction, then bouncing back to the same medium again, right? I think it is more than clear, Lamai. Is it? Sanumi? Sehasa kitnori? Clear the?
Yes,
Clear.
sir.
Right. Right. Then the reflection of light by a plane mirror. This is discussed in grade 7. Uh, right? If it is not clear, I have uploaded some videos from the grade 7 to the YouTube channel, so you can watch them, but they are in single medium. Huh? Right. Reflection of the light by a plane mirror. ඔන්න දැන් අපි මට කියන්න පුංචි කාලේ ලේසර් ටෝච් එකක් පත්තු කරලා තියෙනවද කොහෙට හරි? ඔය ට්‍රිප් ගියාම එහෙම ගන්නෙ. ළමයි අපි පුංචි කාලේ නම් ගත්තා. දැන් කොහොමද දන්නේ? ලේසර් ටෝච් එකක් පත්තු කරලා තියෙනවද ළමයි?
Yes.
very good. සනුමි कितने ली?
No, sir.
No. कितने ली?
No, sir.
right. ලේසර් ටෝච් එක කියන්නේ මෙන්න මේ ඔය නිකන් සෙල්ලම් බඩු කඩවල වල එහෙම තියෙනවා නිකන්. right. මේ වගේ ලේසර් බීම් එකක් යන ටෝච් එක. හරි. ලේසර් කියන්නේ ඇත්තම ලේසර් නෙමෙයි ඉතින් ලයිට් එකක් යන්නේ. හරි. right. You will need a plane mirror, a sheet of white paper, electrical torch or a laser torch, a pair of scissors and a protractor and a pencil. Right. So in here you measure the angle. Right. Kidnuli, you had read this methods.
Method: place the sheet of white paper on the table. Place the plane mirror perpendicular to the paper using a stand. Draw the mirror line on the paper. Direct the narrow inclined beam of light along the paper onto the mirror using the electrical torch or a laser torch. Observe how the beam of light reflects from the mirror. Trace the incident and reflected ray on the paper using the pencil. Remove the mirror and complete the rays using the ruler. Construct the normal line to the plane mirror at the point of incident. Measure the angles at either side of the normal line.
Right. Place the sheet of paper, place the mirror perpendicular to the paper using a stand like this. You can see it in the picture. Draw the mirror line, then you have to draw a line, that means along to the mirror. Then direct a narrow inclined beam of light here. It is easy if you are using a laser torch, right? Observe how the beam of light reflect from the mirror. You can change the direction of the light. You can move your torch from here to here, then you can observe the changing of the reflected ray, right? Observe the beam of light reflected in the mirror, trace the incident and reflected rays on the paper using the pencil, remove the mirror, construct the normal light and to the plane mirror, right? You have to draw the line at the point of incidence. That means here, the point of in incidence is where the light ray touches that means incident ray touches the reflecting surface. That means the mirror, right? Measure the angles at either side of the normal light. So you have to measure, before measuring, you have to draw a line at the middle of the angle. Then you have to measure here the angle of incidence, then the angle of reflection here, right? Then a diagram that shows the way the rays are traveling is known as ray diagram, right? So here we have drawn a ray diagram, right? Ray diagram is a diagram shows incidence ray එකයි reflective ray එකයි හරි ළමයි මොකක් හරි light rays යන විදිය පෙන්වන diagram එකකට අපි කියනවා මොකද්ද? ray diagram එකක් කියලා. right? ඒක මෙහෙම diagram එකක් වෙන්නත් පුළුවන්. එහෙම නැත්නම් මොකක් හරි light rays, right? Like that. Light rays are moving through a direction and it touches a lens. Then it moves like this, right? So if you are drawing this can be named as a ray diagram. In Sinhala, we use the Kirana Satahana, ray diagram, right? So in 14.1, what you have constructed in the ray diagram show the reflection of the light, right? Now you have understood, right? Reflection of the light ray from a plane mirror at its incidence, point of incidence, right? You have to memorize these words: incident ray, point of incidence, and the reflecting ray, angle of incidence. That means the angle which the incidence ray meets the point of incidence or meets the mirror. Then the angle of reflection where the reflective ray is reflecting after incidence ray touches the mirror, right? These angles should be the name of the angles, and this figure should be memorized because you may be given this figure to label at the exams, right? You have the incident ray here, then the reflecting ray, point of incidence, and the angle of incidence, the angle of reflection, right? Then you have few points again. The ray that falls on the mirror called incidence ray, right? You will be asked like this: what is the incident ray, right? What is the incident ray, right? Then you have to give this sentence: the ray that falls the mirror is called incident ray. Is it clear, Lamai? Kitnuri?
Yes.
Right. Explain the second point for me. Kitnuri.
ඉන්සිඩන්ට් රේක මිරර් එකේ කන්ටැක්ට් වෙන තැන point of incident.
Very good. Incident ray එක mirror එකත් එක්ක contact වෙන තැන which means touches with the mirror is the point of incidence. Right? Sehansa, explain the third point. Sehansa.
රේක රිෆ්ලෙක්ට් වෙලා රිෆ්ලෙක්ට් වුණාට පස්සේ එන රේක රිෆ්ලෙක්ටින් රේක
Right. Reflect වුණාට පස්සේ එන ray එක reflecting ray. Right. හරි. The ray that reflects away from the mirror is known as the reflecting ray. හරියට නිකන් මේ කහිර කහ පාටයි කියනවා වගේ වැඩක් නේද? නේද ළමයි? නේද? කතා කරන්නේ. yes sir. නේ? හරි. මම කියන්නම්කෝ. Yes sir. කතා කරන්නේ නැහැ නේ. The perpendicular line drawn to the mirror at the point of incidence is the normal or normal line. Sanubi, what's that? Explain. Sanubi, if you are facing the issue with the mic, you can pass it to your friend, one of your friends. You can type the friend's name that should be passed the question. Right? Mention a name, Sanumi, at the chat box.
point of incident එකේ අඳින perpendicular line එක.
Right. මොකක්ද ඒක?
normal line.
Normal line is the normal or normal line. Very good. Right. Kitnuri, the last point you had explained.
angle එක incident ray එකයි normal line එකයි angle of incident reflected ray එකයි normal line එකයි අතර තියෙන angle එක angle of reflection.
Angle of reflection. Right. Very good. Hari. Then you can do this at your own by using pins. And now, then in the exams you will be asked these terms, right, to label. Then you can read this 14.2. Who is going to read? Sehansa. Sehansa, කියවන්න බලන්න.
You will need a sheet of white paper, a plain mirror, 4 pins, a ruler, a pencil, a protractor, a stand. Method: place the sheet of paper on the table. Place the plain mirror perpendicular to the paper using the stand. Draw the mirror line on the paper. Fix 2 pins in front of the plain mirror which should be on an inclined straight line to the mirror. Observe the images of the pins through the mirror. Fix another 2 pins on the paper which are in line with the 2 images. Now remove the pins and the mirror. Draw straight lines connecting the pin marks. Complete the ray diagram by constructing the normal line at the point of incidence as done in activity 14.1. Measure the angle of incidence and the angle of reflection.
Right. Here, this is the point. Right. You have to use a mirror here. first you have to set a mirror on a white sheet. Then you have to fix a pin in one point. Then in the same line, aligned to the previous one, you have to fix another point and another pin. Then you can see actually a one, if it is aligned at a point, අපි මේ පැත්තෙන් බලන එක අවස්ථාවකදී ළමයි ඔයාලට මෙතන ඉඳන් බලන්න දැන් අපි මේව ගහලා නැහැ. ගහලා තියෙන්නේ මේ දෙක විතරයි. right? අපි මෙතන ඉඳන් බලන අපි අපි මෙතන ඉඳන් බලන එක අවස්ථාවකදී ඔයාලට කණ්ණාඩිය ඇතුලෙන් පේනවා right? මේ ඇන දෙක එක ඉරක පිහිටන අවස්ථාව. right? අන්නේ පිහිටන අවස්ථාවට කෙලින් අපි මෙතන ඇනයක් හිටවනවා. ඊට පස්සේ ඒකටම කෙලින් මෙතන ඇනයක් හිටවනවා. හරි. කණ්ණාඩියෙන් පේන රූපෙ දිහා බලාගෙන ඒක කෙලින් අපි ඇන දෙකක් හිටවනවා. අපි මුලින් මෙතන හිටවනවා ඊට පස්සේ මෙතන හිටවනවා. ඒ දෙක එක කෙලින් ඊට පස්සේ අපි එහා පැත්තෙන් ඇවිල්ලා මේ ඇවිල්ලා බලනවා කණ්ණාඩියෙන්. කණ්ණාඩියෙන් බලලා කණ්ණාඩියෙන් පේනවා එතකොට මේ ඇන දෙක. අන්න ඒක කෙලින් අපි මෙතන ඇනයක් හිටවනවා මෙතන ඇනයක් හිටවනවා. ඊට පස්සේ අපි කණ්ණාඩිය අයින් කරනවා. අයින් කරලා මේ ඇන කෙලින් ඇන ටික ගලවලා ඒ ඇන වල සිදුරු හරහා අඳිනවා. මොකද්ද? ලයින්ස් දෙක. right? මෙහෙම ඇවිල්ලා මෙහෙම එතකොට යන්නේ. right? මෙහෙම ඇවිල්ලා මෙහෙම යන lines දෙක. ඊට පස්සේ we draw the normal line. Then we can measure the angles, two angles. right? Incidence and the angle of reflection. right? I think it is clear ළමයි. clear නේද? ඒක ඉස්කෝලේදී කරාද?
Yes, sir.
Good. right? So we can move to the 14.1.2 reflection, laws of reflection. Right here we have two laws actually. You have to keep these words, the definite word, the exact words in the mind. Right? You can't change the words. You can mix up the words. You have to keep in mind the order of the words and the exact words in these two sentences. Is it disturbing? My neighboring house sounds. Don't mind. Right. Laws of reflection. Shit. Right, love. Right. Observations of the activities. Right. You have to read these few sentences. Sanumi, can you?
Yes, sir.
Very good. Yeah.
Observations of the activities 14.1 and 14.2 can be summarized as follows. When light is reflecting, that the incident ray, reflecting ray and the normal line are in the same plane, that the values of the angle of incidence and the angle of reflection are equal. Above conclusions are true for all the instances of reflection of light. Therefore, they are considered as the laws of reflection. There are two laws of reflection. The incident ray, the reflecting ray, and the normal line drawn at the point of incidence are in the same plane. The value of the angle of incidence is equal to the value of the angle of reflection.
Very good. Right. ඔන්න මේ කියන්නේ මොකද්ද? දැන් same plane අපි බලන්න මේ figure 14.2 එක. right? The incident ray එකයි reflected ray එකයි. හරි? the incident point එකයි point of incidence මේ ඔක්කොම තියෙන එකම plane එකක එකක් උඩ එකක් යට එහෙම නැහැ එකම තලයක තියෙන්නේ right they are in the same plane right it is the first law of incidence it means the incident ray comma the reflecting ray and the normal line drawn at the point of incidence are in the same plane. එකම තලයේ තියෙන එකම plane එකේ තියෙන are in the same plane. All these are in the same plane. Otherwise, if it is more like this, right? මෙහෙම උඩට ගිහිල්ලා වදිනවා. ඊට පස්සේ යටට එනවා. Now they are not in the same plane. Right? Reflected light is going from bottom to top. Then the incidence line is ray is going from bottom to top. Then the reflecting ray is going from top to bottom. Right? They are not in the same plane. But naturally they are in the same plane. Right? The value of the angle of incidence is equal to, that means this angle of incidence is equal to the value of the angle of reflection. Reflection මේ දෙක සමානයි. එතකොට if you are given a one value, right? As an example, if it is 30 degrees of angle, the angle of incidence is 30 degrees. You can judge the angle of reflection. Ne? And you can calculate the angle of the total of the angle of incidence and the reflection. Right? Right. If you are given the incidence ray like question like this, right? A incidence ray touches the mirror in an angle, right? Wait. I will draw it in a better way, right? Now here is the line of the mirror. The incidence ray is here and touches the mirror in an angle of 30 degrees. In angle of 30 degrees. That means now what is this angle, Amai? What is the name of this angle?
Angle of incidence.
Very good. Angle of incidence. Then you are asked to draw the reflecting ray and the angle of reflection. So you have to draw it in again with the angle of 30 degrees. Neramai. And you have to mark the angle of reflection as 30 degrees. Right? I think this is clear. Is it clear, Lamai?
Yes, sir. Yes.
Right. Then we are coming to the regular reflection and the diffuse reflection. So you have regular reflection and there are two types of reflections. There are regular reflections and the diffuse reflections. Right. Let's observe. Right. Mama නිකං සරලව අහනවා. From where now you have experience since your childhood about the diffuse reflection. In where and what is it? කොහෙදීද ඔයාලා හොඳටම diffuse reflection එකක් දැක්කේ පුංචි කාලේ ඉඳලා? කොහෙදීද දැක්කේ? කොහෙදීද දැක්කේ කියන්න බලන්න. දැක්කේ කොහෙදීද? ළමයි දැක්කේ කොහෙදීද? වැවක් ගාවට එහෙම ගියා නෙමෙයි. අපි හිතමු වතුර වලක් කියලා. වතුර වලකට ඉරේලිය වැටිලා ටිකක් ලොකු වතුර වලක් නම් ඒකේ වතුර එහෙ මෙහෙ පොඩ්ඩක් අපි හිතමු විලක් කියලා. right. ඉරේලිය වැටුණාට පස්සේ මේ ඉරේලිය එහෙ මෙහෙ යනව නේද අර රැලි හින්දා. වතුරේ තියෙන. නේද? ආ යනව නේද?
Yes, sir.
right. Because the water surface with waves can be considered as a rough surface. So if the light rays are touching, light rays are contacting a rough reflecting surfaces, it will show a diffuse reflection, right? If it is a plain, smooth surface, right? Like this, it will show a regular reflection. That means conventional reflection. සාමාන්‍ය reflection එක පෙන්නනවා. Right? With the roughness, it goes here and there. Right? Hi. You have to read Sanumi. Let's observe. Read it. Sanumi.
You will need an electrical torch or a laser torch, a plane mirror, an aluminium foil, a joystick. Method: aim a beam of light onto the plane mirror and the crushed aluminium foil separately as shown in the figure 14.4. Observe how the light is reflecting in each instance. Discuss your observations in the classroom. For clear observations, spread some smoke near the setup using the joystick. Note: do not aim the laser rays into eyes as they are harmful to eyes. You may have observed that parallel light rays are reflected parallelly by plane mirror, figure 14.4, and parallel light rays are reflected to various directions by crushed aluminium foil. According to the activity 14.4, it is clear that light reflection is of two types, regular reflection and diffuse reflection. More information of these two types are given in the table 14.4. 2. Regular reflection. This is done by smooth surfaces. Parallel light rays are reflected parallelly. Examples: reflection of sunlight by a plane mirror, reflection of laser rays by a plane mirror. Diffuse reflection. This is done by rough surfaces. Parallel light rays are reflected various directions. Examples: reflection of sunlight by the pages of a book, reflection of sunlight by objects like the earth, plants, buildings, and rocks. Think whether regular reflection of diffuse reflection is commonly found in day-to-day life. Both regular reflection and diffuse reflection are useful in day-to-day life. Instances where regular reflection is useful. Regular reflection is commonly found when using mirrors. Examples: to watch one's own face, to use light microscope, to create vivid light patterns in various shows to get information of the motion of machine parts in industrial plants.
right. ළමයි ඔන්න දැන් අපි දන්නවා rough surfaces වලින් වෙන්නේ මොකද්ද? Light, the incidence ray will be reflected to the various direction, right? But in a smooth plane mirror, it will be reflected to the same direction. Not the same direction, that the reflected rays will go to a same direction, right? According to the activity, the reflection rays are two types. They are regular reflection and the diffuse reflection. So you need to remember this example, one of these examples with this characteristic. What is the main characteristic of a regular reflection and what is the main characteristic of the diffuse reflection, right? And how it is happen, smooth surfaces and the rough surfaces. Now I am highlighting these facts because it will be asked, right? You know, now the regular reflection is happening in smooth surfaces while the diffuse reflection is happening through rough surfaces, right? The parallel light rays are reflected to the parallel આવද parallel માં යනවා මේක නමුත් diffuse එකේ parallel light rays are reflected to the various direction. එහෙට මෙහෙට යනවා තනින් තන වැදිලා. මොකද ඒ වදින surface එක ඒ කියන්නේ ළමයි මේක මේ මැජික් එකක් නෙමෙයි සාමාන්‍ය දෙයක්. හරි. අපි හිතමු surface එක තියෙන්නේ මෙහෙම මෙහෙම කියලා. Right. Wait, right, surface එක තියෙන ඔහොම කියලා. Right. Now the light rays coming in, I will draw it in blue color. The light rays coming to touch here. Then it will reflect according to the law of reflection, right? Always a light ray will follow the two laws of reflection, right? So you can draw a normal line here. I don't think it is well accurate, but roughly you can draw the reflection right. If it is not clear, right? If it is coming like this, it will go here according to the laws of reflection. I will draw the normal line in pink, right? Then again another light ray will touch these small areas of right. Then again another ray will touch this one, and it will be reflect according to the laws of reflection. This normal line should be perpendicular to the surface. Then the reflected ray will go like this. So you can see it will be reflected to the various directions, but the incidence rays are coming parallelly. Right? This is the case. Right? I think this is clear, Lamai. Is it?
Yes, sir.
Right. The parallel light rays are reflected parallelly. The parallel light rays are reflected the various direction. Reflection of the sunlight by a plane mirror. Reflection of the laser rays by a plane mirror. So you have to remember, always a plane mirror will will show you a regular reflection, right? Then if it is a rough surface, like a reflection of sunlight by the pages of a book, පොතක පිටුවලින් රිෆ්ලෙක්ට් කරන විදිය. ඒක නම් ඇත්තටම රිෆ්ලෙක්ෂන් එකක් වෙනවද නැද්ද කියන එක ප්‍රශ්නයක් මේ අචුපතේ දුන්නට මේක. But you have to remember this example also. This is not a best, not a good example because reflection will it happen කියන එක ප්‍රශ්නය. Right? Reflection of sunlight by objects like earth, plants, buildings, and rocks. Right? To the same direction. But one of the best examples are crushed aluminium foil or a water surface with waves, right? They are good examples, right? But you have to remember these two examples also. Thick weather regular reflection of diffuser reflection is commonly found in day-to-day life, right? You have to think. Both regular and reflection are useful in day-to-day life. Meva useful, right? Instances where regular reflection is useful. We can understand where the regular reflection is useful, right? Regular reflection is commonly found in when using mirrors, right? If you are using a mirror in a laboratory, I'm 100% sure, and I'm 95%, I am 99% sure it is used for the reflecting purposes, right? To have a reflection in the laboratory, right? Uh, Otherwise, the use of a mirror in a laboratory is minimum, unless it is used for the reflecting purposes, right? Regular reflection is commonly found when using mirrors to wash one's face. මොකද අපි මූණ බලන්නේ reflection එකේම ප්‍රතිඵලයක් විදියට. අපේ මූණ මෙන්න මෙහෙම ඉන්නවා ළමෙක්. මෙතන තියෙනවා කණ්ණාඩිය. right mirror එක. මෙයාගේ මූණේ ඉඳන් ඔන්න incidence ray එක මෙහෙම එනවා. Alright. ඒක රිෆ්ලෙක්ටඩ් තමයි අනිත් අයට පේන්නේ. මෙයාව මෙතන ඉන්නවා මෙතන ඉන්න කෙනෙකුට පේනවා. ඒ කොහොමද පේන්නේ? මෙන්න මේ reflections හින්දා. right. මෙයාටම පේන්නේ reflection හින්දා. හරි. To create vivid light patterns in various shows. අපි mirrors යොදා ගන්න. උදාහරණයක් මෙන්න මේ. Creating vivid light patterns in various shows by smooth surfaces. Like to get information of the motion of machine parts in industrial plants. Right? මොකද වෙන්නේ? ඇතුලේ මොකද වෙන්නේ කියලා බලා ගන්න අපිට මිරර් එකක් සෙට් කරලා ගන්න පුළුවන් reflection use කරලා. Right? ඊට පස්සේ the instances where the diffuse reflection is useful. Now, where the diffuse reflection is useful. Right? The main in these examples, actually you cannot figure out the now these examples are good, but you cannot figure out, you cannot see the reflected light, right? You cannot see the reflected ray, right? But it gives a reflection, right? Otherwise you cannot see a white page of a book clearly if it is not reflect the light beams which contact with it, right? To see a something, right? To see an object, that object should be able to reflect the light which contact its surface, right? To see an object, if it is not a light source, I am repeating, if it is not a light source like a bulb, light source like a sun, if it is not a light source, if it is not a source of light,